Your phone can find your exact location anywhere on Earth. But have you ever wondered how it actually knows where you are? The answer comes down to simple math and a network of satellites orbiting high above you in space.
GPS stands for Global Positioning System. It is a technology that allows your phone, car, or any GPS-enabled device to determine its exact position anywhere on Earth. But here's something interesting. Your phone doesn't send signals to satellites. Instead, it listens. There are satellites in space constantly sending signals down to Earth, and your device picks up those signals and uses them to calculate where you are. The GPS system works using a group of satellites orbiting high above the Earth. These satellites move in carefully planned paths so that at any moment, multiple satellites are visible from your location. This is very important because GPS doesn't rely on just one satellite. It needs signals from several satellites working together to determine your position accurately. Each satellite is constantly sending out a signal toward Earth. Inside that signal are two very important pieces of information. First, the satellite's exact position. Second, the exact time the signal was sent. When your phone receives this signal, it compares the time it was sent with the time it was received. That tiny difference in time is what allows the system to calculate distance. GPS signals travel at the speed of light, which is extremely fast. Because of this, even a very small delay in the signal can represent a large distance. Your phone measures how long it takes for the signal to arrive. Then it multiplies that time by the speed of light to calculate how far away the satellite is. So instead of measuring distance directly, GPS measures time and converts it into distance. With one satellite, your phone can only determine one thing: how far away that satellite is. But that still doesn't tell you your exact location. You could be anywhere at that same distance. If you imagine this in 3 dimensions, all those possible locations form a sphere around the satellite. So with one satellite, your position is somewhere on that sphere, but we don't know exactly where. Now, let's add a second satellite. Each satellite gives us a sphere of possible locations. When these two spheres overlap, they intersect. The intersection forms a circle. This means your location is now somewhere along that circle, much more precise than before, but still not exact. Now we add a third satellite. This creates a third sphere of possible locations. When all 3 spheres intersect, they meet at a single point. That point represents your exact position. This method is called trilateration, using distances from known points to find an unknown location. Behind all of this is mathematics. Each satellite creates an equation that represents a sphere. The center of the sphere is the satellite, and the radius is the distance to your phone. When you have 3 satellites, you get 3 equations. By solving these equations together, your phone calculates your exact position in space. This happens instantly, every time you check your location. In real-world GPS systems, we use at least 4 satellites instead of just 3. This is because timing must be extremely accurate. Even a very small error in time can lead to a large error in position. Your phone's clock is not perfectly precise, so the 4th satellite helps correct this error and improve accuracy. This ensures your location is reliable and precise. Today, GPS is used in many parts of everyday life. It helps you navigate while driving, track deliveries, guide airplanes, and even locate your phone if it gets lost. Behind all of these applications is the same idea: using satellites, signals, and math to determine position.
So the next time you open a map, remember, your phone is solving a complex geometry problem in real time.
Now you know how GPS uses math and satellites to find your exact location. Subscribe for more simple engineering and science explanations, and don't forget to like and share this video. And check out the next video on your screen.